Okay, so I'm going to go through a real quick video solution set to the 4.4 practice. Um, this, I'll talk more about this when I get back to school, but for now, this ought to be maybe helpful to Algebra 2 students as a way of kind of demonstrating how to do these problems. And a lot of this stuff is sections. The last two sections of chapter or module 4.3 and 4.4 are the by far the easiest part of the chapters. The first part that's I'd say is the more challenging part. Okay, so uh, the the 4.4 assignment's broken into three parts. There's a review of solving linear 2x2 linear systems, so two variables and two equations algebraically, which is algebra 1 stuff, and then we reviewed it last year in geometry. And then I'm going to show you some new things, how to do this with technology, a real convenient way to do this with technology. So problem like this, if we're going to solve this algebraically, remember that there are really two ways to solve a linear system. We can either use substitution or we can use linear combination. I'll just do a real brief sort of description of what those are and go through a couple sample problems. So something like this. Okay, so here's an example where we'd want to use substitution because one of these equations is already solved for y. So we use substitution either when a variable is already isolated or when it's really simple to isolate a variable without introducing any fractions. Otherwise, we would just use the other method, which is linear combination or elimination, whatever you want to call it. So what I always tell my students to do is to put a box around the substitution equation. This equation, y, is isolated. And so we're going to substitute that into the other equation. So where we have a y in the first equation, we're going to substitute in 3x plus 17. So what's that give us? In this first equation, then we get 6x plus 8 times y. And for my substitution equation, y is 3x plus 17. And then that's just equal to 16. Okay, what that does for me is it eliminates a variable. So now I've got a single equation with only x's in it. And so if I simplify this, if I distribute the 8, I'm going to get 24x plus 80 plus 56, what is that, 136 equals 16. And so then if we combine like terms, 6x plus 24x is 30x. If I subtract 136 from both sides, I would get negative 120. And then I've got 30x equals negative 120, divide each side by 30, and get x equals negative 120 over 30 is negative 4. So there's my x value. And now here's why we put a box around the substitution equation, because now we'll just go back to the box and we'll plug in this value of x to find out what y is. And so then when we plug that in, we get the equation y equals 3 times negative 4, which is the x value that I'm plugging in, plus 17. And so that becomes y equals 3 times negative 4 is negative 12 plus 17 equals 5. So we get x equals negative 4, y equals 5, and we want to enter that as an ordered pair, form x, y. So my answer would just be negative 4, 5. So there's an example of substitution. So let's try that one. Okay. Okay, here's a different situation. In this case, neither of the two linear equations is solved for a variable. And it's not really easy to isolate any of the variables. None of the variables have coefficients of 1 or -1, and so it'd be kind of difficult to isolate x or y in any of those equations. So we're not going to use that method. Instead, we're going to use the method of elimination or linear combination, whatever you prefer to call it. So in this method, what we want to do is we want to multiply one or both of the equations by numbers so that we can get either the x's or the y's, the x terms or the y terms to cancel. Well, notice here that the y terms are pretty convenient. If I multiplied the top equation by 2, for example, I'd end up with a 4y, and then if I subtract the bottom equation from the top one, the y's would go away. That's the way that the textbook does it. I always tell my students to set it up so you can add the equations. It doesn't really matter. You can either add or subtract. Maybe I'll do one of each. So in this case, the way I like to show this is if I'm not going to change an equation, I'm just going to draw a straight arrow. So the bottom equation is going to stay the same. It's not going to change. It's going to be -6x plus 4y equals -6. In order to get a -4y in the top equation, I'm going to multiply both sides by -2, because -2 times -2y is -4y. So the way I like to show this is in the middle of my arrow, I'm going to put the number -2, which tells me what I'm going to distribute through both sides of the equation. So if I multiply the left side of the equation by -2, -2 times -5 is positive 10x, -2 times -2 is -4y, and then -2 times -5 is positive 10. Okay, so now, if I add these two equations up, look what happens. The y's cancel. -4y plus 4y cancels. 10x minus 6x, or 10x plus -6x, gives me 4x, and 10 minus 6 is 4. So the y's disappeared, and I get the simple equation 4x equals 4, which gives me a solution of x equals 1. Now what? Well, now I've got to find the y value. So I'll just go back to one of my original two equations and solve for y. Pick the easiest one. In this case, it doesn't really make much difference. I'll just pick the bottom one. So if I plug x equals 1 into the bottom equation, I get -6 times 1 plus 4y equals -6. So what's that give me? -6 plus 4y equals -6. If I add 6 to both sides, the 6's cancel from both sides, and I get 4y equals 0. If I divide each side by 4, I get y equals 0 over 4, which is just 0. So my solution then is the ordered pair, x equals 1, y equals 0. And that's what I would enter in Moodle. Okay? What about one like this? Now notice what happens here. This is already set up in standard form. And look what happens there. If I add these equations up, look what, they're already set up nicely for me. If I add these up, the x's cancel, and the y's cancel, and the -1 plus 1 cancels. So on the left side, I get 0, and on the right side, I get 0. Well, how do we interpret that? 0 equals 0. Well, when is that true? That is always true. And so if I get an equation that is a statement that is always true, that means that there are an infinite number of solutions. Okay? Now another way to think about this is, when we solve a system of linear equations, if I graph either one of these equations separately, they're just lines, right? And so like if I went back, for example, to, if I went back to this previous example right here, for example, if I graphed these two lines, what does that tell me? It tells me, okay, so as I was saying here, if we were to graph these two equations, these are both just lines, right? And this would be the point where the two lines cross. Okay? So for this problem, we end up with the answer 0 equals 0, which is always true. And so that means there are an infinite number of places where the two lines cross. Well, how can that happen? Lines, really, there's only three things that can happen with lines, right? Lines can either cross in a single point, in which case we get one ordered pair like we did previously, or two lines can be parallel and never cross, which would be the case where there are no solutions, or third example would be the two lines overlap. So there's the first line, there's the second line. They're the same line, and so each point on both lines, all the infinite points on each line overlap, and so that would be the case where there are infinitely many solutions. But we know when we're solving it algebraically, if we just get a true statement, if we get an equation that says 0 equals 0 or 1 equals 1 or something like that that's always true, we interpret that as infinitely many solutions. And so that's what I put. Okay. Okay, what about something like this? So this is one where I would definitely use substitution, because at least one of the equations, in fact both of the equations, are solved for a variable. So a variable is isolated. So in this case, let's just take, for example, how about we'll take the bottom equation as the substitution equation. So that means in the top equation, where I used to have a y, I'm going to substitute 2x plus 25. So that gives me 2x plus 25 as my y value equals 2x plus 16 when I make the substitution. If I subtract 2x from both sides, I end up with the answer 25 equals 16, which is nonsense. That's never true. And so that would be the case where there are no solutions. The lines are parallel. And so in Moodle, we would just input NS. Okay. So that's all review. You've done that a million times in Algebra 1 and quite a bit last year in geometry. But this is new. I'm going to show you a trick for an easy way to solve linear systems using your graphing calculator. Okay, so here's what this looks like. So we've got these two equations, and what I want to do is, if the equation is already solved for y, then that's fine. I'm just going to go to the y equals editor, and I'm just going to input these two equations. Oops. Okay, so y1 is going to be the first equation. So this is the one we're going to do first. That's y1. I'll just put it in as it reads. Now, one little trick I always do, you could use the fraction template if you want to. You don't really need to. Well, I'll use it once just to remind you how that works. So we go alpha f1 gives me the fraction template. And so I get, I should put the negative out front, but it's okay if I put it on top. Negative 3 over 4, or I could say negative the fraction 3/4 times x minus 7/4 is the first line. And then what about the second one? Now let's look at what we have to do on this second one to get the y by itself. So what are the steps to get the y by itself? I'm going to in order, I'm going to subtract 4x from both sides, or add negative 4x, same thing. So that gives me negative 3y equals 5 minus 4x, and then I just divide each side through by negative 3. And so I get the equation y equals 5 minus 4x over negative 3. Okay, I would claim that you can do that right into the calculator. You don't even, this algebra is easy enough that you can just do it, you can solve this directly into the calculator. It's always the same thing. You're always just going to subtract or add the x term, whichever one is necessary, to the other side, and then divide by the coefficient of y every time. And so if we want to isolate y, here's one way we can do this. We can use the fraction template. So we'll go alpha f1, and then what's going to end up in the numerator on the other side, we've already got the 5 there, so I'll start with the 5. I'm going to subtract the 4x to the right side, so there's my minus 4x. And I'm going to divide that by the coefficient of y, which is negative 3. So there's my negative 3. So now I've got both equations in the calculator, and I just want to find out where they cross. So I'm going to start off maybe by just going zoom standard, zoom 6. And I got lucky this time. On that window they cross. The nice thing about lines is that they look the same on any scale, so it doesn't matter how big I make the window. And so if, for example, what if the intersection had been off of the screen? Well, then all I've got to do is go to the window and just make it bigger. I could just go like from negative 100 as my minimum x value up to positive 100. And then I don't even have to pick the y's. I could just go, if I pick the x's, I can just go zoom fit, which is zoom 0. Remember that trick. And then the calculator will figure out what the y's should be so my screen looks good. So in this case, it's gotten, the window's gotten really big, but notice the lines still just look like lines. So it doesn't matter how big you make the window, I can still find the intersections pretty easily. So if it doesn't show up at first, expand the window. All right, so if I want to find where these cross, this is really simple on the calculator. I go second, calculate, and then I just choose intersect, which is number 5. And then all I ever have to do if I'm solving where lines cross is just hit enter 3 times. Once to verify the first curve, once to verify the second curve, and once for a guess. And there's my answer. The intersection is at, let's see, what are we supposed to do here? Let's look at the directions. Round to the nearest hundredth. Okay, so the ordered pair, the x value, you can see on there is negative 0.04. The y value, it gave it to me as a fraction. And the reason it gave it to me as a fraction, that's a little bit inconvenient. It gave it to me as a fraction because I used the fraction templates, which is why I don't like to use the fraction templates. So what I would have to do in this case is, whoops, gotta find that again. Is I'd have to find out what negative 43/25 is. So on my calculator, to find that y value as a decimal, I would just go negative 43 divided by 25 gives me negative 1.72. Okay, there it is. Okay, let's do another one. Okay, so I'm going to do this one without the fraction templates. I think that's a better way. So we can just solve this right into the calculator. So y1, we'll use the top equation for y1. So if I want to get y by itself in the top equation, what are the steps I'm going to have to do? Well, I'm going to start off, here's what the algebra would look like, right? I'd have 10x plus 7y equals negative 18. So I'm going to subtract 10x from both sides, which gives me 7y equals negative 18 minus 10x, and then I divide each side through by 7. Okay, on the calculator, an easy way to do that would just be to say, here's what I do. I'm going to, if we're looking at this top one, I'm going to open a set of parentheses that represents the numerator. Well, whatever number is already on that side is going to be part of the numerator. There it is. I'm going to, in this case, subtract 10x away from both sides, and that ends up also being in the numerator. So I subtract the x term to the other side, and then I divide the whole thing. So I'm going to close the parentheses, which means I'm going to take that whole thing divided by the coefficient of y, which is 7. So that's an easy way to do it, right? Open a set of parentheses, start with negative 18, subtract 10x to that side, close the parentheses, and divide the whole thing by 7. Okay? And then the other one down here, whenever you want to deal with a fraction as a number, like here in this case we have y2 equals negative 10/7 times x, one easy way to do that is just to put it in parentheses. So negative 10 divided by 7 in parentheses times x minus 18/7. And I can put the 18/7 in parentheses too if I want to. So there are my two equations solved for y. Now I'm just going to go zoom 6, and we'll see if we can see the intersection on the screen. Wow, what do you know? The two lines overlap perfectly. Okay, so that means that there are infinitely many solutions. Okay, that was easy to see in this case because I have the fancy color edition where I could see that the first line was blue and the second line was right over the top of it. If you don't have the color edition, you wouldn't see that as easily because you wouldn't see the color change when the second line was graphed. So the way you could do this, if you have a regular TI-84, is you could just turn one of the equations off at a time. So if I turn the first equation off by unhighlighting the equal sign, look what happens. Then there's the second equation right there. Now we'll go back to the y equals editor, and we'll turn the first equation back on and turn the second equation off and graph it, and it looks like the same line. So that would be a way that I could, if these weren't color coded, that I could see that they're both the same line, and so I get IM. Okay, let's try another one. Okay, how about this guy? Let's practice putting these directly into the calculator. So I go to y equals, clear these, and then remember what my strategy is. So the first one, I'm going to solve for y. So I'm going to open a set of parentheses. I've already got a 4 on the right side. I'm going to subtract 10x to the right side of the equation, and then divide the whole thing by negative 12. Okay, I don't have to simplify this. The calculator's smart enough for me just to leave it like that, and it'll know how to graph the line. So there's no sense risking making a mistake by simplifying this. Just isolate y into the calculator. So what about the second one? We start with a negative 1 on the right side. Open a set of parentheses and start with a negative 1. We're going to subtract 5x to the right side, close the parentheses, and then divide the whole quantity by negative 6. Okay, so let's try zoom 6. Okay, now what about that? Those lines look like they're parallel. Okay, so how do we know if they really are parallel? Well, here's a trick. We can go to the calculate menu, and we're just going to ask the calculator what the slopes of each line are. Because remember, if lines are parallel, they have the same slope. Well, number 6, that's our fancy calculus way of saying slope. So we're going to choose option 6. And then we're going to be on for y1, which is the bottom line. Notice it says y1 up here. If I hit enter, it tells me that the slope is 0.8333 repeating. Okay, so now we'll just repeat. Actually, I think if I go up, no, I have to do it again. So I go second calc, I go back to slope, and this time I'm going to use the up or the down arrow to go to the second line, which is y2. Notice it says y2 up here, and I hit enter, and notice it tells me that the slope, which remember is dy dx, is the way we say that in calculus, but that means slope, is 0.83333 repeating, same as the other one. So those two lines have the same slopes, and they are parallel. And we can kind of see that even just in the graph, that those lines appear to be just parallel. Okay, so if they're parallel, they never cross, and so the answer is NS. Okay? Okay, last two. We got these real-world problems involving 2x2 linear systems. So let's look at something like this. These are not hard problems. Don't be intimidated by the fact that there are words. Okay, so here's the situation we've got. So we've got these two car companies, or these two rental companies that charge, they have different pricing structures. The first rental company, Drive Time Car Rentals, charges a flat fee of $44.88, plus they charge 20 cents per mile driven. Okay, so what we want to do, so there's the way that they do their pricing. The other rental company, Penny Pincher Car Rentals, does not charge any flat fee, but they charge a higher mileage rate of 86 cents per mile. We want to set up a 2x2 linear system with two equations and two variables, or two unknowns, and solve that in order to answer these two questions. After blank miles, both companies will have charged the same amount. So one unknown is how many miles have we driven? And then the other question is asking, at this point, the break-even point, both companies will have charged how many dollars? And so the other unknown is the price. So typically in problems like this, the two questions that are being asked represent the two variables, right? So we've got the two variables are miles driven and total price for each rental company. So we need to determine which one of those is the input variable or the independent variable, and which is the dependent variable or the output variable. Well, wouldn't it make sense that the price would depend on how many miles that you drove, right? So we could say that X equals number of miles and Y equals price. So those are my two unknowns. And I'll, honestly, you could call either one X or Y. It wouldn't make that big a difference. Later on, it's going to be nice in math to always try to get the X variable to be the independent one. But you could do this either way, as long as you're consistent, and it would be fine. Let's do it this way, though. So now we want to use those two unknowns, and we want to set up a linear equation representing each of the two car rental companies' price for the number of miles driven. So let's color code this. Let's look at Drive Time Car Rentals and make this red. They charge a flat fee of $44.88 plus 20 cents per mile. Well, that's the rate, 20 cents per mile. So 20 cents per mile times the number of miles driven tells us the amount that we're paying for the mileage rate for that car. Plus, we also have to pay just a flat fee regardless of how many miles we drive of $44.88. So doesn't that look then, the red equation should look like, I'm going to put this right here. So the red equation should look like the price, which is y, is equal to the rate, the mileage rate, 20 cents per mile, times the number of miles driven, which is x, plus the upfront fee, the one-time fee of $44.88. So there's the equation that represents drive time car miles. What about penny pincher? Penny pincher car rentals does not charge a flat fee, but charges 86 cents per mile. So this time the price for penny pincher is equal to the rate of 86 cents per mile times the number of miles is x, and that's it. There is no flat fee. So we've just got to solve that linear system. Okay, that's not a big deal. We can do that on our calculators real easily. Those are already solved for y. So we'll make the top one y1, bottom one y2. So the top one is going to be 0.2x plus 44.88. And the bottom one is just 0.86x. And we'll try zoom standard, but it's not going to work this time. We don't see anything. We see one of the lines, but we don't see the other line. Okay, so we've got to make it bigger. So let's go to the window. Really, we might as well just start x at 0 because we're not going to drive negative miles. And then we'll just go out, I don't know, let's just try like 250 miles, and if that doesn't work, we'll make it bigger. So we're going to let the number of miles on the graph, the left edge of the graph will be 0, right edge will be 250. And then I'll just hit zoom 0 and let the calculator figure out how to scale the y values on the window. And all I need to be able to do is see the intersection, which I do. So once I can see the intersection, then remember the trick. I go second, calc, 5, and then triple enter. Enter, enter, enter. And it tells me the intersection is at 68.48. So we said that x represented, remember, the number of miles. And so the number of miles is 68, and after 68 miles, both companies would have charged $58.48. So it wants us to enter those in order separated by a comma. So filling in the blanks, the first one was 68. Second one was how many dollars? 58.48. Notice I'm just filling in the blanks. I'm not including the dollar sign. It's already there. And we got it. Okay, last one. Okay, what about this? So, similar kind of problem here. Okay, so principal at Riverside Middle School purchased graphing calculators and tablets for math classrooms at her school. She bought 19 graphing calculators and 47 tablets for a grand total of $12,979. After 1 month, they were so popular, she purchased an additional 15 graphing calculators and 22 tablets from the same supplier for $6,863. So the question asks, what's the cost of each graphing calculator and the cost of each tablet? All right, so those are the unknowns. So let's just go ahead and say, let's let x equal cost of graphing calculator, y equals cost of tablet. And let's look at each of these two situations and color code them and turn them into equations. So how about the first situation? She bought 19 graphing calculators and 47 tablets for $12,979. Okay, so if X represents the cost of a graphing calculator, then doesn't it make sense that 19 times the cost of a graphing calculator X, that's going to represent the total amount she paid for graphing calculators, plus 47 times the cost of a tablet, which is Y, all adds up to $12,979. Okay. The other situation was when she bought 15 graphing calculators and 22 tablets from the same supplier for $6,863. So that one would be 15 times X plus 22 times Y equals 6,863. So there's my linear system, and I can just put that into my calculator. Okay, so if I take this first equation and I isolate y into the calculator, whoops. To get that y by itself. So remember, I'm going to open up a set of parentheses for the right side of the equation. I've already got a 12,979 over there. I'm going to subtract 19x, subtract that 19x to the right side, close the parentheses, and then divide the whole thing by 47. And for the second equation, I'm going to open a set of parentheses. On the right side, I've already got a 6,863. I'm going to subtract 15x. The 15x I'm going to subtract to that side, close the quantity, and then divide the whole thing by 22. And then I think it's really unlikely if I graph this, if I hit zoom 6, it's very unlikely I'm going to see anything because those are pretty big numbers. And so let's go ahead on the window and let's let this go from 0 up to, let's see, we're trying to find the cost of these. What would be a reasonable estimate? I don't know. Let's just say 250 again. So I'm gonna let X represents the cost of a graphing calculator. So it's got to be somewhere between $0 and $250, I would say. So that's what I'm going to set the X min and the X max, and then I just hit zoom 0, which is zoom fit. Remember, so the calculator will do the thinking and pick the Y values for us. Okay, that worked. I can see the intersection, and so I just go second, calc, intersect, and then triple enter. Enter, enter, enter. And it tells me that the X value is 129 and the Y value is 224. Well, remember, the X value represents the cost of a calculator. So if I put this stuff in there, then it just wants these in order separated by a comma. So the graphing calculator cost 129 and the tablet cost 224. Okay, that's it.